So the question becomes, how do you write a chemistry test, and what does a chemistry test even look like? And you probably are thinking that the how to write the chemistry test is going to be a pretty obvious answer, but having done this for a long time, I can tell you that it's not as obvious as you think it would be. Some of your parents struggled with this, and I know because I was there doing it. So I'm going to try and walk you through some things that I think are helpful, but we also want to talk about what the test is going to look like. So for me, a chemistry test is always going to look kind of the same thing. It's about the same size, and I always start with about a test about that size. I don't pick a particular number to aim for, so if you like nice round numbers, apologies in advance, you're not going to have that happen. Regardless of whether the test is a little bit bigger, a little bit smaller, it's always going to be weighted the same, so at test is at test. I normally have about 10 to 15 questions in multiple choice, probably closer to somewhere in between all of that. Again, I don't work with a particular number. We'll talk about what those multiple choice questions cover and what's a good strategy for answering them in a little bit. Then there's going to be some written answer. I sometimes call it medium answer. When we have units with calculations, that'll go in there. When we have longer answers with descriptions or explanations, that's going to go in there. Diagrams like Lewis diagrams and Bohr diagrams, that goes in there. So the bulk of the test is going to be within the written answer. And then there's almost always, I'm going to go back to there. This was coming up later, but it's here now. So if you see the word describe in the written answer, then it means tell me about the what. And if you see the word explain, it means tell me about the why. And then that means giving reasons, which usually means talking about theory, so atomic theory, for example. I'll give you some examples of that in a second. And then part C kind of depends a little bit on when in the week we're having it or what else has been going on, but there's usually going to be a nomenclature. So in the same way that you've had nomenclature quizzes, you're going to have a nomenclature section on the test, and I usually work with about 10 marks. 5 questions of each kind. So basically what I would have used as a nomenclature quiz gets dropped on the test as a nomenclature section. Now if you take a look and do the math, you'll notice that if the whole test is worth about 40 marks and the nomenclature is worth 10 of those marks, it's pretty important to be able to do nomenclature well, because that makes up about 25%, give or take, of the test. So you want to know your nomenclature. It's not easy marks, but it should be marks that you don't have to work super hard to get. Okay. When we're talking written answers, that was kind of why I thought that other stuff was happening here, although I'd probably repeat myself. My suggestion is read the full question, okay? Because that's one of the things that people run into a lot. They'll skim read the question, or they'll only read part of it, and then they start answering the question and they miss something. So make sure you've read the full question. Personally, and this is maybe me more than other people, get to the point, get to it quickly, and then get out of the way. A lot of people, what they'll do is they'll hit a question or they'll hit a test maybe and say, I've studied all this stuff, I've learned all this stuff, I want to show everything I know. And that's awesome, except I don't want to read all that. I just want to read the answer to that particular question. And if I'm reading at about line number 4 and you haven't told me anything that answers the question yet, I'm going to assume that you don't actually know what you're doing, you don't know what you're talking about, and I'm going to stop reading. And what some people do, I kind of think, is they have this strategy of, I don't know what I'm really talking about, so I'm going to talk a lot. Bad strategy. Not a good strategy. Get to the point, get to it quickly, move on. And then make sure you actually answer the question. And that kind of goes back to that thing about describe versus explain, but also make sure that you are, well, answer the question. We'll try and do some examples. That would probably work better than me just coming up with larger ideas. Okay, so if I try to ask a similar kind of question but using different words. So if the question says describe the radius trend in forming positive ions for 2 marks, honestly I'm probably not going to ask that question. I am going to answer it, but I probably wouldn't ask that question because describing it's not that big of a deal. I struggle to find 2 marks worth of it. So if you're thinking, wow, do all my answers have to look like that? No. But what I would be kind of looking for is that you tell me what a positive ion is, lost electrons, and then what that means for the radius. The radius gets smaller. You're not going to see that question because why would I ask that? A much more interesting question in the same theme is to explain the trend in the radius when forming positive ions for 3 marks. Now my answer here is probably a little bit longer than what it needs to be because I tried to use more or less similar stuff or the same starting point as the previous question, but then get into the explain, the reasons why. It would not be enough in this one just to say that positive ions are smaller, because that doesn't answer the question of explaining the trend. It tells me what the trend is, but doesn't tell me why the trend. And you certainly would not say, well, the trend is left to right, top to bottom, because that's not the reason why. That's just saying what the pattern is. But in this case, the trend happens, or that the reason that the radius changes size and gets smaller is because now you've lost electrons, so there's fewer electron-electron repulsions and stronger nucleus to electron attractions. So it nucleus pulls the outer electrons in. And yes, in the case of positive ions, most often we've also lost an outer energy level, which automatically makes that ion a little bit smaller. Having said that, because of that, and because I've shown you this, I wouldn't ask that particular question, but there are other ones I could ask. Multiple choice questions, I know you're thinking, well, multiple choice is easy, the answers are right there, but what I'm telling you is, having done this for a really long time, multiple choice questions catch people a lot, and you don't want to have that happen. So again, read the full question. Identify keywords, and I'll show you an example of that in a minute. Something creative scribbles, what I've noticed over the years is that people who kind of figure things out in the margin or in the space along the question usually do a better job than people who have a really nice clean page and just sort of dive to the answer. It's not a magic trick. It's not that, oh, as long as I scribble something in the margin, I'm more likely to get the answer, but it does mean that they're actively thinking things through. It's probably not going to happen a lot where you have, 2 options where you can automatically eliminate those, but there should be one option that you look at and think, no, that's probably definitely not it. And then I always have 4 options on my multiple choice answers, and if I can't think of a good 4th option, I'll usually use not enough information. But understand this, I'm really not likely going to ask you a question that you cannot answer. What would be the point? So if you see not enough information, that is never, or at least almost never, the answer that you're looking for. I'm going to ask you a question that you can answer, because I want to know what you know. So what do I mean by creative scribbles? Well, I gave you a question earlier that I think could be answered using creative scribbles. So the question was this: ionization energy. How does it change? What causes the ionization energy to go up? Is it the atomic radius getting bigger, the atomic radius getting smaller, the atomic number getting bigger, or the atomic number getting smaller? Well, what do we know about the ionization energy? Well, that was one of our trends in the periodic table. So personally, I would scribble out a quick little periodic table. I don't have to make it super neat. I don't have to label anything. And then I would remind myself what the trend was. Top to bottom, the ionization energy goes down. Left to right, the ionization energy goes up. So which one of those which one of those options meets that trend? Is the atomic radius getting larger, smaller? Is the atomic number getting larger or smaller? And it turns out that in this case, the atomic radius is getting smaller as the ionization energy, it's right there in front of me, as the ionization energy gets bigger. Okay. Identifying keywords. I've actually used this question before, and that top option should not say A. I'm sorry I missed that, but that should just be a question. Which ion is isoelectronic? I don't know what isoelectronic means. Well, good. I gave the definition. As chlorine ion. Okay, so one of the first things you need to do is identify how many electrons are in that ion of chlorine. Turns out there's 18. Okay, which ones are the same? Or which one is the same? So you count through the electrons in each one of those particles, and it turns out that there are 2. Now, I've had people come to me during the test and say there are 2 answers to this question, and my answer is always, that's weird. And then that's it. I don't answer anything more. But if I identify the keyword as ion, that means I can eliminate the one option in there that's not an ion. Argon is not an ion. Calcium, 2+, is an ion. So there are other examples where we could get into some things like that, but what I want to do is at least get you started on the idea that in a question you're going to have to think, you're going to have to be careful. The question answers hopefully don't all jump off the page and poke you in the eye, but it's all manageable and it's all based on stuff that we've done. And yes, you'll probably see questions where we haven't talked about it in class, but it's all part of the same stuff. So think about what we know, think about the things that we've done. How does that apply to that situation? Okay? And I wish you all the best on it.